Testing 1, 2, testing 1, 2. Okay, I think I've got things working a little bit better now. So, hello to my one streamer that's out there, or one watcher that's out there. I'm just trying to figure out some technical issues that I'm having. So, I was going to do a kind of a demonstration of the inside of a Cessna 172 cockpit with Allie, but I was having some technical glitches last night, so I thought I would try doing it this way. P900 Cool Picks, if you're still watching, could you drop in the live chat a description of how bad the audio is sounding and how bad the video is looking? On my end, it looks like it's pretty laggy. All right. Well, I think I've got some of this figured out. I'm going to switch over to using the voice meter output and see if I can get both the airplane sounds and my voice to go through. All right, I'm going to try doing sound now. Sweet. Thank you, Peanut and Henry Colpix. I'm still trying to figure out all this stuff. I sent a invite to Allie, but it's probably going to take a second. I know this is like watching paint dry, but I appreciate your help. I'm really trying to get it with the engine sounds too. Oh, that sounds terrible though. Yeah, thanks P900. I'm also monitoring it using a sock account, so thank you for that. All right. Okay, well, I think I finally just decided to give up on trying to use voice meter and OBS and all that stuff. So, all right. Well, let's see if I can adjust this. Oh, hey, Allie. Now I see you're in there. All right. Yeah, so I'm fighting some bandwidth issues and having a real devil of a time getting streaming to work. And just to make things worse, for some reason now I can't hear my aircraft and stuff. So, yeah, it's being stupid. Hey, FPV Angel. So, yeah, this is going to be a real quick one. I just kind of wanted to get in the flight simulator, which I haven't used in like a year because they broke the rudder pedal configuration and stuff, and I was having a real devil of a time flying with it anyway because I'm used to having forces of motion acting on me. So first off, can everybody hear me? Does my voice sound roboty or screwed up or anything? Oh, sweet. Okay. I just wanted to wait for that because I figured there's no point in me talking if it's going to, just sound horrible. So let me move one thing here. My apologies for the extra noise on the desk, but I don't need my tablet because I'm not running OBS, so that's kind of a waste of time. All right, so this is the cockpit of a Cessna 172. It's the aircraft I'm most familiar with. I actually do a lot of training in November 54342, which is a really old, like 1968 Cessna. But this is pretty much what it looks like in the inside, except my seats are all ripped up and torn up, and the floor is falling apart, and all the upholstery needs to be replaced. But it's a training aircraft, and it's been around forever. So yeah. So I thought I would run through um, what the instruments are real quick inside the aircraft. We'll actually go through a real startup procedure on this, and then we can take it up in the air, and I can show you a couple of the misconceptions people have about aircraft and how they actually work. So the first thing I need to do is pull up my checklist just so I have that. And I apologize to everybody for being woefully unprepared, but I was trying to get things, set up. And this is really the first time I've gotten into the whole streaming side of YouTube. So I was debating if I want to do this live or if I want to do it, um, you know, just recording a video. Because, I mean, a video would be a lot higher resolution and probably clearer, and I can do that. So, but yeah, I figured, well, let's go ahead and try this. And if it ends up being a dumpster fire, then oh well. And I'm going to see if I can pull out my chat here on my other screen just so I can hopefully see. Yeah, that's being stupid too. So I will pull it up on my phone. There we go. So, Cessna 172 cockpit. Now, if you watched my gyro video, you'll remember that I said when you start up the aircraft, your gyro is going to be kind of cocked over into the side. And finally, X-Plane actually modeled that correctly, which was kind of one of the things that was annoying me as a gyro tech. So this one, yeah, that's pretty much what you would see in the cockpit. It's tilted over the side and pitched up about 20 degrees, and the power flag is in the off condition. So let's just go through the 6 main ones. We call this the 6-pack for obvious reasons, and I'll start at the top left here. So this is the airspeed indicator. The way the airspeed indicator works is it functions off of the pitot tube on the Cessna 172, which if I learn how to zoom out here, that's this funky looking little L-shaped guy right there in the center of the screen. So that's your pitot tube. And what it does is it's basically just a ram air intake. And so the air coming in exerts a pressure on some mechanism inside the pitot tube, and that gets compared to what's called a static patch, which is down underneath the seat here on the outside of the aircraft. And between those two measurements, it's able to tell what the relative airspeed of the aircraft is. So the airspeed is measured in knots. Aviation got stuck with the convention of using knots and nautical miles way back when aviation first started, and we've just kind of stuck with it. Don't ask me to do the conversion in my head because honestly, I can't remember it. It's too early in the morning. Right next to it is the directional gyro. This is the one that I took apart on my channel. And you can see that it's currently leaning over to the side like it's supposed to be. The directional gyro is what tells you how much you're pitched up, pitched down, and how much of a bank you're in. Doesn't necessarily tell you the rate of your turn, but it just tells you how much you're banked left, right, front, and back. The altimeter here is basically just a fancy barometer. It reads the barometric pressure off the static patch. That's the thing that's on the bottom of the seat there, or actually up underneath the aircraft. And it uses barometric pressure to tell you what altitude you're flying at, because the higher you go, the lower the pressure ends up being. And you'll notice if I really zoom in, whoa, that was way too much zoom. Right here, we have a calibration dial that is calibrated in inches of mercury or millibars on this side, depending on where you're flying. And as you fly, the air traffic control will give you the current local barometer at the nearest weather station that you're flying over. And that's accurate enough to keep you in your little block of air that you're assigned to fly in. Now, going down to the bottom left, this is your turn coordinator. It's a gyroscopic instrument as well. It basically tells you the rate of any turn, as well as provides an indication of how much the airplane is slipping. Slipping is when the tail kind of skids out from behind the aircraft. Like if you don't properly coordinate your turn by using the rudder, the aircraft will skid. Sometimes you want to intentionally skid the airplane, like if you're doing a forward slip to lose some altitude because you set up your approach a little bit too high. But most of the time you want to keep this ball right in the center. And literally all it is a ball in some very, very thin fluid, and it always wants to drift down. And if you're properly coordinating your turn, then the force of the turn should be aligned right down the center line of the aircraft, so this ball should stay right in the middle. Next to that is another gyroscopic instrument. This is the directional gyro. This is basically a gyroscopic compass. This is the one that I was saying that you have to adjust periodically during flight because it does precess quite a bit. And I think the rule is if you anticipate that you're going to need it to make a turn accurately, you're supposed to realign this every 10 minutes or so. And then right next to this, that's your vertical speed indicator. I'm drawing a blank on how this works, but my intuition is telling me it has something to do with the pitot tube and the static patch. But basically, it tells you what your vertical climb and descent rate is. So that's very key information to have if you want to, descend into an airport without scaring the crap out of your passengers. So that's the six-pack. It's airspeed, attitude, altitude, turn coordinator, directional gyro, and vertical speed. Most everything else on this aircraft is pretty boring. It's the stuff you got in your car. So you've got a clock, you've got an outside air temperature gauge, fuel gauge, exhaust gas temperature, fuel flow, engine temp, oil pressure, vacuum, because in some aircraft, the gyroscopes are actually powered by an air vacuum instead of an electric motor. This aircraft, I think, is simulating all electric gyros, so I'm not even sure why it has a vacuum meter, but X-Plane didn't consult me. And then the battery amperage. Down below your six-pack is probably the most important instrument, and that's your RPM meter for your engines. Generally, when you're flying, you're setting a specific RPM, and then you get whatever performance you get out of the aircraft based on that RPM. So if it's a colder day, you'll get better climb performance out of your aircraft than a hot day. But your RPMs and your safe RPM range for a particular condition of flight, whether you're climbing, descending, and all that, comes from your pilot operator's handbook, and you just set the appropriate RPM for the activity that you're doing. Now, next to all of those instruments, you've got your three navigational aids. These two are VOR radios. They basically allow you to fly to VOR transmitters, which provide navigational information for aircraft. This one has a little bit of extra information where you can actually follow a glide slope. So you could use this for an ILS approach, which is they have an extra set of beacons at the end of the runway that help guide a plane down when they're flying through, super thick clouds and can't see the runway. You can actually follow these arrows straight down to the runway, and it'll keep you aligned. You keep 2 of these on board because it's really handy to have one tuned for your next waypoint, one tuned for the waypoint you're currently following, and then in the radio stack, you can just switch them back and forth. Below this is your ADF DME, not DME, ADF direction finder. I personally have never actually messed around with this in the simulator, so I don't know if it's actually working, but it's another type of navigational aid that basically just gives you a compass direction to follow to a beacon on the ground. It's a little bit less accurate than the VORs, but it can work over much longer ranges than the VOR. So it's kind of a handy device to have if you're going way cross country. Fuses, just like your car would have under the dash. There's a whole bunch of them, one for every instrument. This stack over here is going to be our radio stack. It's simulated off of a Garmin radio stack. And below that is our POS X-Plane autopilot, which, yeah, this thing is not realistic in the least, but so looking at the center column, just real quick, panel lights. This is our throttle. If I move my joystick throttle in and out, the knob moves in and out. You push to add more power, pull back to add less power. Next to that is the mixture. Mixture allows you to change the ratio of air to fuel so that when you're at a higher altitude, you can get more air in because obviously you have a lesser density of air coming into your engine, so you need more of it. When you're lower down at sea level, you need less, and so you can, leave it all the way in. So that's full rich. This is full lean. If you pull it all the way out, the engine will stop. Boom. Fuel selector switch. Rudder pedals down on the floor. That's how you control the tail. And light switches. So I'm going to go ahead and turn power off. I'm going to go to view on the external, and we're actually going to go take a quick flight. So I'm going to do circle, and there's our aircraft. So the first thing you do when you get to the airport is you do a walk around. You'll go around the aircraft and you'll make sure that everything is still attached to the aircraft that's supposed to be attached. You look at all of your rivets on the side. You look at your propeller. You actually pull on things. It's a fairly detailed process. You go ahead and check your fuel. One thing about your fuel tanks is they get condensation in them. So on the bottom side of the wing, there is usually a little port. I think it's not modeled here, but somewhere back here, where you can actually bleed the water out of your engines because you don't want water getting down into your engine. Obviously, that would be really bad. So you do your walk around, you make sure your control surfaces move free. Nothing's gotten rusty overnight. No cables have frayed. Some of these areas have little access panels that you can actually look inside, but for the most part, you're just going to go in and make sure that all your control surfaces work good. And a friend of mine was kind of confused about this the other day, so I'm going to go ahead and explain this. So the Cessna, all the controls are obviously not hydraulic. They're cable driven, so you can actually operate them while the plane's not running. And I think most of us are familiar with building paper airplanes, and you have one that wants to nosedive in the ground, so you bend, the tail edges up. So that's how the elevator works. Is this pulls up, the nose of the plane goes up, you push down, the tailplane angles downward, that causes your nose to go down. But here's the part that confuses people for some reason. So if I want to make a left turn, notice what the wings do. The left side goes up and the right side goes down. And that confuses people because I think they're looking at all the control surfaces as like the tailplane. But the way this works is when your aileron goes up, it actually causes that side of the wing to lose lift. And that causes that side of the aircraft to dip. Consequently, if you lower the aileron down, it actually increases the amount of lift on that wing and causes that wing to go up. So you notice we do them in opposite directions. So, right now, right wing goes up, left wing goes down, left wing goes up, right wing goes down. So don't let that confuse you. For some reason, I've had a couple of non-aviation people get bothered by that. So I'm going to go ahead and say that we've done our pre-flight inspection. I'm going to go back inside the cockpit if I can figure out where the buttons have moved to. There we go. So back inside the cockpit. Nice thing about this is I can hide or show the yoke as needed. So I'm going to go ahead and leave it off, and I'm going to put the plane back into a cold and dark state. So this is how you would find the aircraft with everything shut off. So the first thing I'm going to do is I'm going to turn my battery on. That brings up my fuel gauges here. I can see that I've got fuel on board. That's good. Notice it doesn't really spin up the gyros or anything. So I'm going to go ahead and turn on my beacon. That's going to let anybody that's going by know that somebody's inside the aircraft and getting ready to fire things up. And I'm going to give the safety briefing. So I'm going to describe what our flight's going to be. So I think today we're going to go just take a quick flight from Rocky Mountain Rocky Mountain Airport, used to be called Jeffco. Fly down to Colorado Springs. We're going to pick up the Fort Carson VOR on our way so we can kind of see how that works. So we're going to fly from the northwest down to here. We're going to make a U-turn, and we're going to land right here at Colorado Springs Airport. I think on, let's do 35 left. So we'll go for 35 left here. Okay. So hopefully it won't be too long of a flight, but I'm going to do some air maneuvers on the way. So that's the basic plan. So the safety briefing. If we, after we take off, have a engine failure, we are not going to try to make the impossible turn and circle right back around and go back to the airport. We are either going to try to make it to Boulder, or we are going to land in one of these nice, convenient open fields that we have over here. That's actually how I would brief people. So I think that's it for that. Hopefully we won't have a engine failure. So let's do our engine start checklist. Mixture full rich. Don't need to prime this engine. Master to on. Got to turn my nav lights on. Set my brakes. Okay. Toes on the brakes. Okay. And we're ready to start. So I'm going to turn this over. There's our prop. And notice it gave me a warning right off the bat. Directional gyro is now aligned with magnetic north. Yeah, we know. That's because it kind of gets stuck at wherever it gets stuck at when you stop the plane. Put in 1/4 inch of throttle. Looks like everything's good there. Now I'm going to do my checks. Oil pressure's in the green, temperature's in the green, fuel flow's in the green, vacuum's coming up, amperage is in the green. Really don't care about the vacuum. I'll set this for 800 RPMs. And yeah, I think we're good. So at this point, I would go ahead and check the weather. I'm going to go ahead and turn my avionics on. Go back into my map. Okay. Come on, details. ATIS 126.25. So now we have to check the weather. Every airport has an automated system that will give you the weather in real time. And unfortunately, I don't have my audio coming in, so you won't be able to hear the terrible robot voice. But at the top of the screen, it's going to read off Rocky Mountain Metropolitan Information, India, 1500 Zulu weather, wind calm, visibility is more than 10, sky clear, temperature 3, dew point minus 1.5. The altimeter is 29902. Arriving runways 30 right, 30 left. Departing runways 30 right, 30 left. Advise on initial contact that you have information India. So what that all means is that every weather broadcast has its own letter assigned to it. And whenever the weather's updated, they increment to the next letter or sometimes a random letter. And so whenever you contact the tower, you have to tell them that you have that particular weather report, that you've actually listened to it, and then they know what the weather report is, so they can verify it. The weather report basically said that it's 1500 Zulu. Everything's done in Zulu, which is what, Greenwich Mean Time. The wind's calm. The visibility is more than 10. That's all you need to fly. The temperature's 3. The dew point's below that, so we don't really have much to worry about icing there. The altimeter is 29902, so I'm going to go over and I'm going to set my altimeter while I'm here. So, come on, mouse. 29902. You see how that moves the needle on the altimeter. All right, so I can zoom out. We got our weather. We're going to do a VFR flight, so we don't need much information. And here we go. So what I would do now is I'd actually contact ground and ask for taxi directions to the active runway, and they would tell me where to go on the airport to take off, and I would roll out of here. This is going to be less than impressive because I know this thing is laggy as hell because of my internet connection, but give you some idea of what goes on here. So I would actually call the ground controller, which conveniently is on my other radio, and I would say something like, Rocky Mountain Ground, Cessna November 172 Sierra Papa is at Rocky Mountain Aviation. Request taxi to the active, VFR departure to the south. And that just tells him that I'm at Rocky Mountain. I'm going to be flying visual flight rules, so I don't need a lot of controller input. And I'm going to be flying south, so he's going to give me a south turnout so that I can just proceed on course without getting in anybody's way. So he would probably come back and say, November 172 Sierra Papa, Jeffco ground, taxi to and hold short runway 30 right via Alpha 1, contact tower when ready, something like that. I would read that back just to make sure that we're all on the same page, and I'd be cleared to taxi, which is what I'm going to do now. So I'm going to bump up my RPMs just a hair. I'm going to release my brakes. I'm going to take my full brakes off. I pull a little power in, and I'm going to start rolling. And hopefully my rudder pedals are cooperating. Yeah, it seems like they are. Yeah, there's still a little touchy, but it's not too bad. Now, if I take the airplane too fast, they're going to get really touchy. So I'll try not to. In fact, what I might want to do is, since there's nobody actually looking, I might just do a midfield departure because I don't have to worry about anybody landing on top of me because I'm in the simulator. So I'm going to stop here and I'm going to show you what this sign reads up ahead. So these yellow signs tell you where you are and where you're going. Notice that it says A with a left and right arrow. That means that the vertical taxiway that is right here is going to be taxiway alpha. That's the one that I want to take to the runway. So I'm just going to go up and join that. And then I'll pick off a random turn-off spot. How jerky is the video coming through? I suspect it's coming through really jerky. Yeah, I still need to tweak the sensitivity on these rudder pedals. All right. I'm just going to do a midfield. I'm going to see if I can pull over here and get onto the runway. Oh, that was a really sharp turn. I'm going to do like a midfield departure, because I don't want you guys to have to wait around forever to watch me take off, and it can take me forever to get down to the other end of the runway. Hopefully I've got enough runway left here. I don't know. We'll find out. So the one thing I am going to do is I'm going to show you what we do in a run-up real quick. So the idea of a run-up is to make sure that the props and stuff don't fall off the aircraft. So there we go. Got my brakes set. So what you do is you run the RPMs up to 1700 RPMs. And then I'm going to turn off one half of the engine and listen to what it sounds like. And you get a little bit of an RPM drop. It's not supposed to be more than 125 RPMs. It's right about 90, so that's good. Let's take it back to both. Goes back up. That's good. Recovered nicely. Do the right magneto. There we go. Drops down. And back to both. While I'm down here, oh, forgot to turn my taxi lights on, turn my landing lights on, turn my strobes on, turn everybody on. There we go. All right. Well, we passed the run up. Nothing's going to explode. We're going to assume that tower has told us to go ahead and take off. So I'm going to step on the brakes, take off my parking brake, and roll us out onto the runway. All right. Boy, it's hard to fly the simulator. No sense of control. So I'm going to set my directional gyro using the rudder heading because I know that the rudder heading is exact. So I'm going to set this for 030. I'm going to set my heading bug for a southerly direction. All right. Got to turn on my yoke because I don't need to get down there anymore. I'm going to zoom out. Heels to the floor. Gas undercarriage mixture prop is on. Okay. Landing gear are welded to the frame. A little bit of right rudder because the aircraft wants to turn left. And we're going to roll down the runway. We're going to rotate at about 60. That means we're going to start pitching back at 60 knots. Oh yeah, we got plenty of runway. We're doing this with no flaps, so I want to build a little extra speed. And I'm off. I'm going to try to do this whole flight without autopilot. I'm drifting. There we go. I'm going to zoom in a little bit here. So right now, I'm just kind of picking up a little bit of an instrument scan. I'm going to pitch up here and look at my airspeed because the best climb rate in this aircraft is at 70. So I'm going to try to keep it right at 70. Got my trim worked out good. I'm basically hands-off stick at this point. A little bit of crosswind I'm fighting, and I'm drifting quite a bit to the left because I'm not paying attention. It's a lot easier in the real aircraft because you can feel when your plane's moving. And so you know when you're drifting a little bit to the right. Here I actually have to visually scan and look at everything, which is obnoxious. And what I'm doing is I'm setting kind of a sight picture of, I want the mountains that are dead ahead to be basically at the top of my dashboard there. And that's a pretty good sight picture for this particular climb. And then I'm just looking out the window and holding it. There we go. Just letting the plane rock back and forth a little bit. So once we get up to 7,500 or so, I'm going to go ahead and make my turn to the left and start heading south. I'll zoom out now. I think I've got my aircraft not being a jerk to me. There we go. Could probably get a little bit more climb speed out of it. The air's cold, which means it bites into the propellers better. And it also gives you a little bit more lift because the air is denser than if it was like 75, 80 degrees outside. So there we go. All right, that's close enough. I'm going to go ahead and make my turn to the south. And a kind of balloon there. There we go. Now, this feels like a good, comfortable altitude, so I'm going to go ahead and trim the aircraft to hold this. If you look down here, there's a trim wheel that I can maneuver up and down using the electric trim control on the yoke. And trim basically adjusts your elevator so that it will hold you straight and level if you're flying at a particular speed. You don't trim for pitch, you trim for a particular speed of flight. So I'm going to trim this for a little bit less than what I'm doing here. And I'm going to give it a little bit of nose down trim. There we go. Perfect. So I want you guys to kind of look at what's going on with the vertical speed indicator here. So all aircraft, when they're flying, and right now I'm flying without my hands on the stick, like at all. I don't even have the autopilot on. It's just sitting down here saying ready. And the aircraft is maintaining its orientation pretty well. But I want you to notice what's happening with this vertical speed indicator here. All aircraft, whether you realize it or not, are constantly flying in what's called a phugoid. Basically, it works something like this. So I zoom this like this. So if I pitch my aircraft up, I start to gain altitude, but look at what it does to my airspeed. I start to lose airspeed. As you lose airspeed, you lose lift. Eventually, it gets to a point where you can no longer maintain the proper lift, and so the aircraft will start to nose downward. Now, when you nose down, you start to fall, and your aircraft starts to pick up speed. This increases your lift. So now you seesaw back up. You start to lose airspeed again. It stabilizes out and it falls. Right now, I'm sitting here with no hands on the controls whatsoever. I'm not doing this. The aircraft is doing this just on its own. That's how aircraft flies. They're constantly flying in an up and down kind of seesaw sine wave motion, just because they're constantly going up a little bit, losing airspeed, hitting equilibrium, falling back down, gaining airspeed, and over and over and over and over again. I just managed to put us into a very exaggerated phugoid there by pitching the aircraft up. But with an aircraft trimmed properly for the speed, it will pretty much hold the altitude that it's at. The only thing that would affect it going relatively straight and level is if I suddenly were to cut the power. Now you're going to see the airspeed fall. You're going to see the nose go down. I suddenly add in power. Now the aircraft starts to rise back up. So I'm going to set, I'm going to set 2100 RPMs. I'm going to lean my mixture out a little bit. And I'm going to trim my aircraft to hold us relatively level at that RPM setting. Okay. So I am looking at the live chat. Does anybody have any questions on that part of it? Anything about the instruments or anything about that phugoid motion of the aircraft? And just to be clear, the only reason why the aircraft flies in that phugoid is because it falls. As it falls, it picks up speed, which gives it more lift, and it just goes back up and down. And this is partly why you don't have to like adjust your orientation of your aircraft as you fly, because you don't have to dip your nose. It's going to dip for you. Zoom out here. I'm going to give you an exterior view since I've got this here. But because I know I tend to screw this up, I'm going to go ahead and turn the autopilot on. Somehow. See, I don't really like this autopilot because it's not a very realistically modeled um, autopilot, but especially not for a Cessna. But I'll go ahead and turn on the heading hold and the altitude hold, and basically it's going to try to fly me right on this red bug on the directional gyro, which I just noticed is a little bit off. So I'm going to go ahead and adjust that. There we go. That looks better. Okay. So I'm going to give you an exterior view here, just so you can see around here. This is beautiful Colorado. The airport we took off from is quite a ways away straight behind. I never bothered to map the controls for this, so I'm doing it with the keyboard. That's less than ideal. But yep, this is the front range of the Rocky Mountains right here. We're going to kind of putter over and head on down to Colorado Springs. And I think what I'm going to do is I'm going to pull up the VOR, and we'll try to navigate to that because right now it's not going to be in range, I don't think. So, wow, that is the worst track I've ever taken. Look how curvy that is. This red line will show you the path that you're taking on the ground, and boy, I did a terrible job flying. It's awfully hard, though, when you can't feel every little buffet in the airplane for you to stay straight. But so got that tuned into nav 1. I'm just tuning the navigation instrument that we're going to try to use here. So W. So this instrument here is what we're going to try to follow to run into that navigational aid that's down by Colorado Springs. And it's fairly simple to run. You tune your navigation radio to the station of the beacon, the frequency of the beacon. And it's called a VOR. So you actually tune the VOR right here. And then you can set your compass card on here to the radial that you want to fly towards the beacon on. And if you notice here, there's a little compass rose, and it has magnetic north at 0 and goes all the way around. And I know just from experience that the angle that we're taking down the front range, if we fly into the 150-degree radial, which is this 1.5 right here, if we were to fly a course right across this on the 150-degree radial, that would give us a good setup for turning around and coming back into Colorado Springs. It's not actually the published approach for it, but it's a nice, straightforward left-hand turn, pretty much straight on the final, and you're ready to go. So for demonstration purposes, it's kind of a nice one. So I've got that frequency tuned into my nav radio. And by changing this compass card here, I've told it that I want the radio to tell us when we're flying over the 150-degree radial. And it'll do that by deflecting a needle on this display, which we'll get to see. Now, right now, we're probably a little bit out of range, especially at this altitude. So these two windows here are going to have red flags indicating that it currently can't pick up the signal. But as we get a little bit closer, we'll start to see this in operation. So I'm going to go ahead and unpause. And I'm going to turn this a little bit to the left. And I can go over some of the other interesting things on the aircraft here. So a lot of people have asked me what this step looking thing is here, this weird U bracket. This is actually called a strut step. And it's so that you can stand on the strut and look up on top of your wing so you can reach the gas cap that's sitting up there so you can inspect the top of the wing. There's a bunch of reasons why you might want to get up there. And so it just gives you a convenient and safe place to put your feet while you get up on the wing and look at things. Obviously, this is the pitot tube. That's what gives you your airspeed and not your altimeter, but gives you your airspeed. On most 172s up here, that's where your outside air temperature will be. But this one has a digital outside air temperature. So you can actually cycle through and see it's in 29 degrees Fahrenheit. These are just like the air ports in your car. Let's see, there's not much of interest up there. So while we're en route, this would be much more interesting if I could do it with the sound. Eventually, maybe I'll get that sorted out. But what I'm going to do is adjust my mixture first. I'm going to demonstrate a stall. So what happens when a stall is that you eventually end up with too low of an airspeed to actually generate lift on the wings. And at that point, the aircraft starts to just plummet. And because of some of the weird geometry in an aircraft, you have, the torque from the engine is going one way, so they tend to have left turning tendencies. And because of how the stall actually forms on the wing, it doesn't necessarily, the entire wing doesn't necessarily stall at the same time. It's kind of a gradual process, either inside out or outside in, depending on the design of the aircraft. But once you get to a certain critical airspeed, you no longer have enough lift over your wings to actually continue to fly, and your aircraft will stall. Now, normally I would be practicing this maneuver at a little, no, I got 3,000 feet of altitude. That's probably good. Almost 3,000 feet altitude. And obviously I'm not being super picky about maintaining my altitude. Normally I'd be flying 200 feet higher than this, so that I would be in an actual configuration for flying VFR, because all visual flight rules aircraft fly at 500-foot increments in between the thousands. So if you're flying a course of 0 to 179 degrees, you fly on odd number thousands of feet plus 500. Anything from 180 degrees all the way back up to 360, even numbers of thousands of feet. So if you were flying west, you would fly at like 8,500. If you're flying east, you would want to fly at 7,500, because that keeps you gives you automatic separation from aircraft going the opposite direction. Which obviously, if it's a head-on with aircraft, you have less time to react. So that's why we keep them separated by 1,000 feet going opposite directions. Because that would be really bad if you had a head-on. You have almost no time to react. So I'm going to do what's called a clean power off stall. I'm not going to have flaps down and go into slow flight, which is one of the things you do in training. I'm just going to do a nice clean power off stall. I'm going to zoom the instruments in here a little bit so you can see. If you look at the airspeed, you'll see it has a white arc here. That's the safe range where you can deploy your flaps. And it has a green arc down here. That's your the range of normal flight that you want to stay within. Anything below this green arc is where a stall starts to develop. So what I'm going to do is I'm going to turn off my autopilot and I'm going to intentionally stall this aircraft. And I'm going to do it after I do a clearing turn. Come on. Man, these rudder pedals are sensitive. Oh, and you know what? I forgot to turn my autopilot off. That's why I'm flying like an idiot. There we go. All right, I don't see anybody around me. So I'm going to fly out this way and do a stall. So this is what happens in a clean power off stall. This is typically the type of stall that you would see on takeoff. So I'm going to, actually no, this would be the type of stall you would see on landing because you're coming in power off. And if you pitch the aircraft up too much, it's going to stall and then smack into the runway. So I'm going to reduce my power. And at the same time, I'm going to pitch my aircraft up. And I'm basically just going to try to hold it right there at the horizon. Pulling my throttle back, pitching my aircraft up, pitching my aircraft up. Now we're really losing airspeed. I've got my throttle all the way out. And the stall horn's coming on, at least in my headset. It's starting to chatter at me. And now we are fully in a stall. The left wing dips. I add in power. And I bring the aircraft back up. So you notice that the aircraft, when I got fully developed into the stall, the nose immediately began to fall and the left wing began to dip. It began to fall because this aircraft is what's called passively stable. So basically, it's like a dart that you would throw at a dartboard. It has a center of drag that's behind the center of mass, and so when it goes into a stall and it starts to fall, it tends to fall just like a lawn dart, and it'll just pitch forward and go straight down. So I'm going to zoom this back out a little bit. I'm going to do the same thing again just so you can kind of see how it develops. So I'm going to pull back on the stick. I've got my throttle completely out. We're losing speed. We're losing speed. The aircraft is starting to become very difficult to hold in place. I'm having to put a lot more jerkiness into my stick. Now the stall is starting to develop. They're really having a hard time holding things. It's bouncing all over the place. And there's the stall. There's the spin. I pitch the aircraft back down. I add power. And I recover. Now, given enough time, an aircraft will actually recover on its own from a stall like that if you just leave it alone. In fact, one of the best things you can do if you find yourself into a stall is literally just kind of let go of the stick. Let the aircraft do what it wants to do. Like, I'm going to go ahead and do one more stall here. I'm going to do a really sharp one. I'm just going to let it go. Aircraft's going to pitch down. We're building up plenty of speed. And there, the nose is coming up all on its own. And there we go. We're pitched back up. Now we're in a giant, huge, steep fugoid. So I'm going to go ahead and arrest that with the stick. And there we go. So that's a power off stall, a clean power off stall. And again, that's the kind of stall that you would get when you're on final right before you land. If you can imagine, you're dragging the airplane into the runway, you cut your power, you've got your flaps and everything down, and you think, oh, I'm going to hit the ground. So you pull back on the stick real hard. And because you're at such low airspeed, you instantly jerk it into a stall, only now you don't have enough time to recover, and the wheels smack into the ground and breaks the plane, kills us all. So we don't want to do that. Now it's possible to get into a stall with full power on, and I'm going to demonstrate that here too. So I've now released the stick, and I'm just going to let the aircraft kind of climb. I'm going to trim this up slightly. So I've got full power in, but you notice that my airspeed is really starting to go down. In fact, it went down so far that my nose wanted to come down. So I'm going to raise my nose up. I've got full power still in. And my airspeed's still declining. The aircraft's becoming difficult to control. And there's the stall. Left wing dips. Now we're fully in a spin. All I'm going to do is let the aircraft do it at once. Calm down. Give it a little bit of rudder. And settle us down. Now, Allie, if you're watching, look at what happened to our gyroscope. We actually we got it in such a spin now that thing is precessed off by quite a bit. Now, the curious thing, the thing I'm really curious about on this new version of X-Plane is that they've actually modeled the way the pendulous vanes and stuff work inside the gyroscope, and if this thing is going to level itself back out. So what I'm going to do is turn us back on course and put the altitude hold back on. There we go. Heading back south. And I'm going to put altitude hold on. Come on. Okay, so there we go. Got everything leveled back out. Well, look at this gyro. I'm going to see if it's doing what it would do in real life and precessing itself back to level. And it could be an optical illusion for me, but it kind of looks like it almost is. I'm going to see if I can get this on screen fully. Yep. Yeah, it definitely looks to me like it's leveling itself back out. And this is actually really good. This is pretty well modeled. It's going at about the rate that I would see on the Scoresby in the shop when I would mis-erect it, and then I would bring it back to level and wait for it to self-erect. So yeah, actually this is pretty representative of what I've seen in the gyro shop. So that's kind of a cool detail. I'll have to tell X-Plane that I really like that because, yeah, that's exactly what it would look like. And you can see, really, if I was flying, I wouldn't be paying any attention to this at all while it's sort of misaligned because at this point in my flight, I'm spending more time looking around out here, checking for aircraft, looking at the scenery, occasionally coming back and checking my instruments to make sure that I'm not screwing myself up on anything. But oh, we finally picked up the signal for the VOR. So let's take a look at how this works. So this flag down here at the bottom tells us that we're flying to the VOR. Once you fly over the top of the VOR, it'll change from to from, and that tells you that the VOR is behind you. This needle here is saying that the 115 or 150-degree radial that we want to follow is somewhere off to our right slightly. And so our aircraft is turned to fly because I've got it in nav mode. It's doing this on its own. It's turned off to the right so that it can intercept the 150-degree radial to that VOR, and then it's going to turn right to 150 degrees. Let's see, 1, 2. Directional gyros off. There we go. Actually, it looks like it's a little bit more than that. There. So now the needle is getting closer to vertical. That means we're getting closer and closer to the radial. And when it's right up this, right down the center, then that means you're following right on that radial. And the way to think of it is this thing is putting out 360 beams of radio waves, one per degree in every direction. And you are following one of those beams of radio waves right into this navigational aid. And we're way up here. This is when we were doing all of our stalls and stuff. And so we're going to fly until we intercept that 150-degree radial, and then it'll fly straight and level right down to this navigational aid. All right. Now I know FSX, when I had that, it had time acceleration. Oh my god, it's too early in the morning. It had time acceleration. I could probably speed this up to get us down there, but actually, why not? Oh, we've now intercepted the 150-degree radial. So you see this needle is now straight up and down. And if you look at the track that we're taking on the ground on the GPS, we're currently flying a track of 166, which is pretty close. You can see now the needle's drifting off the other way because the nav on an autopilot isn't really good at adjust our vertical speed here. 500 feet per minute climb, get over those mountains. But the nav hold is not really good at following the needle very accurately, so it kind of overshoots every time, and then undershoots, and then overshoots, and yeah, it's much easier actually if you want to fly that radial super accurately to just do it on your own than it would be to try to do this. So I'm going to go to the outside view and take a look at the mountains here. So far, does anybody have any questions on any of the stuff that I've kind of showed you? Throw them in the live chat because for some reason I can't get the chat to work in the Hangouts window, and it's kind of being stupid. All right. Well, since nobody has any questions, I think what I'm going to do is just accelerate this up to doing an approach and landing. And I hope it makes sense now to I saw a couple of questions about why aircraft don't have to dip their nose. I hope the fugoid explanation made sense to at least some of you. Because yeah, you don't have to dip your nose on a globe even, because what's going to happen is as you start to go over the curve, the aircraft's basically going to dip it for you because you're constantly flying in that fugoid motion. You know, as you get farther away from the planet, you're going to lose you're going to lose speed, which makes you lose lift, which causes you to fall. So you really don't have to constantly dip your nose. I hope that part at least made sense, because that's one of the worst arguments I think is, you know, aircraft should have to dip their nose. No, not really. I mean, the aircraft's just going to fly at the altitude and speed that you've got it set for. As long as you've got it trimmed, it's just going to hold that. So I think they added this in, and I've been wanting to try it, so I see no reason not to try it now. I'm going to do a final approach on 3-5 left. Oh, and by P900, I'm sorry, I missed your text, or I missed your chat. So have a good dinner. All right. Pause. So this is final approach up to the runway that I had picked. And I managed to get myself a little bit out of whack here because I had way too much throttle and everything. But I'll kind of run you through doing an approach, and hopefully this won't be my worst landing ever. So first thing I'm going to do is look at where my trim's set, because I had autopilot on. And, oh yeah, it's basically trimmed for takeoff. So I'm going to trim that a little bit higher up. There we go. And I'm going to look out, and I'm going to straighten my aircraft out because, ugh, good Lord, that was a mess. So, trim this way down. And this is the problem you run into with trying to jump ahead, I guess, in simulator. So I'm going to reduce my power, get us down in the white arc so I can lower flaps. And it lost my mapping, so I'm going to go ahead and throw in one notch of flaps and unpause. Got to get us over to the side here a bit. There we go. So one thing I want you to notice on landing, if I zoom way in here, so there's our runway. We're going to try to land right in this black smudge here as best we can. And you notice to the left side of the runway, there's 2 white lights, 2 red lights. This is what's called a PAPI. It's a precision approach something indicator. Boy, my brain is just shot today. I did way too much training on people yesterday because my brain is not working. But basically, if all 4 of the whites are light, that means you're way too high in your approach. If all 4 of them are red, then that means that you're way too low. And if you got 2 white and 2 red, that means you're right on the proper 3-degree glide slope to come in and land safely. So the first thing I do when I'm setting this up is I'm going to look and see what the lights ahead of me look like and check my glide slope. So now I'm a bit low because I've only got 1 light, so I'm going to increase power. That's going to arrest my rate of descent. I'm going to balloon this a little bit. And this is why I don't like jumping ahead. So now I've got 2 white, 2 red. I'm going to get us into a slight descent. I'm just keeping the threshold right on my dashboard there. So that white stripe at the threshold, I'm trying to keep right at the dashboard. So I'm a little high. I'm going to settle the plane down. There we go. So I'm still a little bit high. I'm going to cut my power completely out. I'm going to do this with 1 notch of flaps. So I'm going to carry a little extra speed into the runway. There we go. I'm going to look down the runway. And I'm just going to hold the plane off, hold the plane off, hold the plane off. And past the threshold. And rear wheels down, front wheels down. Boy, I was way off the center line, but I'll take it. So now I can cut my throttle. And if I wanted to, I could go full braking and stop right here, but that seems kind of silly. And there you go. So now we're on the ground. I'm going to do something really, really bad and take a wrong direction high-speed entrance as an exit because it's a simulator and I don't care. I'm not using best practices here. And now that I'm free and clear of the runway, I could say, welcome to Colorado Springs. This is Colorado Springs Airport. So, yeah, I hope I know the technical quality was crap, but hopefully I answered a couple of questions. I'm going to take my stepdaughter out and do something with her. And then I'll probably set up a stream later this afternoon. If anybody that was in this one wants to talk or ask questions or anything, I'll be able to pull stuff up and actually answer them live. So until then, I'm Newton. This has been a terrible production quality version of Fact-Based Living, and I'll talk to you again soon.